Post-quantum cryptography in Kubernetes. Here is a scary fact. Right now, hackers are recording your encrypted internet traffic, your banking data, your company secrets, your Kubernetes cluster communication, all of it. They cannot read it today, but they are saying it because they know that in a few years, quantum computers will let them decrypt everything they have collected. This attack has a name. It is called Harvest Now, Decrypt Later. And according to our 2026 survey, 87% of companies say they are planning to fix this. But only 7% have actually done anything about it. Today, I am going to explain what is happening, why your Kubernetes cluster is at risk, and exactly what you can do about it. Even if you have never heard the word quantum before, you will understand everything by the end of this video. Let us get started. Okay, let me explain this in the simplest way possible. Think of encryption like a lock on your front door. Right now, the locks we use on the internet are called RSA and ECC. These are like really good locks. To break them, a normal computer would need millions of years, so we feel safe. But quantum computers are different. A quantum computer does not try keys one by one like a normal computer. Imagine you have a lock with a million possible combinations. A normal computer tries each combination one at a time. 1, 2, 3, 4. A quantum computer, it can try many combinations at the same time. Not thousands, not millions, many more, all at once. There is a specific algorithm called Shor's algorithm that a quantum computer can run. And this algorithm can break RSA and ECC in hours, maybe even minutes, instead of millions of years. Now you might be thinking, but quantum computers are not powerful enough yet, right? And yes, that is true today, but here is the important part. NIST, which is the organization that sets security standards for the entire world, has already made an announcement. They said that RSA and ECC should be deprecated by 2030 and completely disallowed by 2035. That is not some faraway future, that is less than 4 years from now, for the first deadline. And remember the Harvest Now Decrypt Later attack I mentioned? That is happening right now today. Intelligence agencies have confirmed that nation-state attackers are already collecting encrypted data. They are just waiting for quantum computers to catch up. So the question is not, will this happen? The question is, are you ready? So if quantum computers can break our current locks, we need new locks, right? That is exactly what post-quantum cryptography is. Let me call it PQC for short. PQC is a set of brand new encryption algorithms. These algorithms are designed so that even a quantum computer cannot break them. The beautiful part, they run on your normal, regular computers and servers. You do not need any special quantum hardware. NIST spent years testing these algorithms. Researchers from all over the world tried to break them. And in 2024, NIST finalized the winners. The first one is called ML-KEM. Its old name was Kyber. Think of ML-KEM as the new lock for your door. When two computers want to talk to each other securely, they use ML-KEM to agree on a shared secret key. This replaces the old RSA key exchange. The second one is called ML-DSA. Its old name was dilithium. Think of ML-DSA as your new signature. When a server sends you a certificate saying, I am who I say I am, it uses ML-DSA to sign that certificate. This replaces the old ECC signatures. Now, here is a smart thing the industry is doing. Instead of switching from old to new overnight, they are using something called hybrid encryption. Hybrid means you run both the old algorithm and the new algorithm together. If the old one gets broken by a quantum computer, the new one still protects you. If someone finds a bug in the new one, the old one is still there. Double protection, like having two locks on your door instead of one. Now, let us talk about Kubernetes, because this is where it gets real for DevOps engineers. Your Kubernetes cluster uses TLS encryption everywhere. When the kutal command talks to the API server, that is TLS. When the API server talks to etcd, TLS. When the kutal talks to the API server, TLS. When your microservices talk to each other through a service mesh like Istio, again TLS. And what encryption is TLS using right now? RSA and ECC, the exact algorithms that quantum computers will break. So if you are running a Kubernetes cluster, every single internal communication channel is potentially vulnerable to the Harvest Now Decrypt Later attack. Now here is the good news. Kubernetes has already started adding PQC support. Starting with Go 1.23, the programming language that Kubernetes is built in, there is experimental support for the ML-KEM hybrid key exchange in TLS. And since Kubernetes 1.31 and above uses Go 1.23 or later, your cluster can already negotiate quantum safe TLS connections. Red Hat OpenShift 4.20 went even further. They enabled PQC support across the API server, kubelet, scheduler, and controller manager. So if you are on OpenShift, you are already ahead. But here is the catch. This is not turned on by default in most clusters. You have to know about it and you have to enable it. And that is exactly what most companies are not doing. Okay, so what should you actually do? Let me give you a simple action plan. Step 1, inventory your crypto. Find out what encryption algorithms your cluster is using today. Check your TLS certificates. Are they RSA 2048, RSA 4096, ECC? You need to know what you have before you can change it. You can use tools like OpenSSL to inspect your certificates. Step 2, check your Kubernetes and Go versions. Make sure you are running Kubernetes 1.31 or above with Go 1.23 or later. This gives you access to the experimental PQC support. Step 3, learn about crypto agility. This is a very important concept. Crypto agility means building your systems so that you can swap out encryption algorithms without rebuilding your entire application. Step 4, start testing hybrid mode. In a staging or development environment, experiment with enabling the ML-KEM hybrid key exchange. See how it affects your cluster performance. Step 5, talk to your team. Most DevOps teams are not even aware that this is coming. Share this knowledge. Bring it up in your next sprint planning or architecture review. The companies that start early will have a smooth transition. The companies that wait until 2029 will panic. Let me leave you with this thought. The shift to post-quantum cryptography is one of the biggest security transitions in the history of the internet, and it is happening now. If this video helped you, please hit the like button and subscribe. I will see you in the next one.